Hello everyone and welcome to the next lesson. In this lesson we are going to be looking at tapers. Now tapers we highlighted are one of the design considerations that look at when you're designing your auxiliary lanes. So you can find the notes on the link that we've shared earlier, but also in your lecture notes you can find details regarding this. So the first thing is, what are tapers? Tapers, their main purpose, as we highlighted earlier, the main goal is to make sure they approximate the path for the driver. So they help you understand how the driver will maneuver from the main lane into the storage or the auxiliary lane. And you find that tapers are designed based on a ratio. So normally the ratio is between 1.8 to 15.1. And again, what we mean by this is, let's just change to a red color here. So what we mean by this is the taper ratio is the change. So I've drawn it like as if we're moving on the left hand side. Let me just draw it. Let me highlight a much clearer way. Let's get that erased. So let's say this is how traffic is moving in this lane. And then we have this taper. So this taper ratio is what we are talking about. So it's the change in the two distances. For example, if the lane is 3.5, okay, so it's going to dictate a minimum taper. So if the taper ratio roughly is 8, that gives something roughly over 20 or something meters. So for those who are in feet, lanes maybe roughly we could say they're around 10 feet. So that means the taper ratio, if your taper ratio is 8, you find that if you have 10 feet, you're going to have something like 80 feet of length in terms of the taper ratio. But that's just the starting point. So you have a 1:8 ratio, but at the same time, you can have 15:1, depending on how you design the junction. And we're going to just highlight where we use the different tapers. And also the other thing you should notice is there are 4 types of tapers. There's the straight taper. It's just straight. You don't have anything. So we have the partial tangent. So we're going to highlight also again, we have the symmetrical reverse and the asymmetrical reverse. So we are going to start with the first one, which is the straight and also the partial taper. And you're going to find that these are the most frequently used. In most of your designs, I think 70% of the time you're going to find that you're using a straight or a partial taper. And you find that these are normally applicable where there's a paved shoulder and it is striped to delineate the auxiliary lane, which is going to be your normal convention. Now you find that they're highlighting that in case of long tapers, a short curve is desirable. We highlight that in point B. So let's first look at the first one, a straight line taper. As I mentioned, you have this, and then this, and then that. And then what's happening is, as I highlighted, you have traffic coming in that direction. You have a taper. In this case, they're saying length should equal to 100 to 180 feet. So roughly in meters is 30 to something. And you find that this comes to that ratio of 1:8 that you're talking about roughly in those cases, based on the lane that you have. Now they've said that part B is, you're going to find that if you have a very long taper, it will be a short curve will be desirable. So it will be good to have a curve here. If you're looking at how this is placed, we have a curve here and also a curve there. So if these are really long, you can have curves on both of them. That's normally desirable. So in week 2, where we're designing these junctions, we shall look at a way of implementing that. So the next is the reverse curve taper. Now the reverse curve taper is, we are mainly going to be talking about how that is done. Now the short curves here we talked about, they're very short. They're not that. So a reverse curve taper is more of a turn curve radius that has 2 curves. They're just continuous. Okay, so you have one taper goes into the reverse curve of another. While in this case you had like straight, 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 and then you have curves in those areas. But now we have two reverse curves. And you've maybe seen this everywhere you go. You find that if you have a reverse curve, they're normally in the ratio of 2 times. So if maybe you have a given radius at one point, you have to get it 2 times the other for that. And you will find that in this case, as we're highlighting in the notes, they are normally continuous. So we have symmetrical reverse curves. You know what that means is the reverse curves are symmetrically equal, like they are symmetrical. While asymmetrical, one curve is not similar to the other curve in terms of symmetry. It may not be, they don't have the same points of intersection. So for example, if that point of intersection is there, these two are the same if they're symmetrical. If they're symmetrical, you may find one curve starts earlier than the other. And you will find that these are suitable for areas where we have very low speeds and where the taper length is greater than 100 feet. So what they're highlighting is they want, for you to make it easier for you to design this, you have to find areas on how you smooth out the two curves. So the situations where we look at designing this is areas where the taper length is greater than 30 meters or 100 feet, and the two curves can fit smoothly because you find that maybe each curve roughly is around 15 meters, which is around 30 feet. If you want to understand more how to design the tapers, there's a lesson in week 2 which is dedicated to showing you how to design both of these tapers. Now in that lesson we also talk about the asymmetrical and the symmetrical, and you understand the difference. So otherwise, I hope to see you in the next lesson.